So here we go. Yeah, so the company I'm going to be speaking about today, or the topic I'm going to be speaking of today, is mainly drinking water. Common issues with drinking water. And then we're going to talk about how you solve some of those issues. So some treatment devices. And the main focus here is kind of residential or light commercial treatment devices. So nothing like at a huge scale. And that's really all to help us kind of frame a discussion on a newer type of technology called membrane capacitive deionization, or MCDI. And then we'll get into a new product that Pureleau is launching called the eCaptis. And I promise this isn't going to be too long. I've only got 10 slides, and I've even got a little slide counter in the bottom there so you guys can see how we're progressing. Okay, so common issues with drinking water. And so most of us get water from our municipality. And aside from, H2O, we're mainly dealing with salts and, small amounts of organic matter. So as you all know, probably, when salts dissolve in water, they become ionic. And so the positively charged ions that you're dealing with are mainly calcium, magnesium, sodium, potassium. And on the negative side, you've got carbonate, bicarbonate, chloride, sulfate, and nitrate. So one of the ways to kind of measure the quality of your water is through something called total dissolved solids. Municipal Health Canada has sort of guidelines around, the bare minimum, and that's kind of 500 ppm. And typically they're going for less than that. Generally speaking, all our municipal water is very safe to drink, but it sometimes has aesthetic issues around taste, odor, color, turbidity, salinity, that sort of thing. I've got a photo in the top right of something that you can actually see. And that shows a little bit of turbidity. It's a recent photo from Vancouver. They sometimes have issues with sediment. And so you can kind of see it in that picture. At least I think it's sediment. On the bottom here, I've got a scale showing PDS from 0 all the way to the Health Canada guideline there, 500 ppm. And then I've got a line here that shows you Victoria and just how lucky we are. So based on what I'm measuring out in Saanich, it's roughly 30 ppm. And I'm sure Chris Lowe would have lots to say about that number. But yeah, as you can see, if you kind of look at some of those bracketed elements, we're right down with reverse osmosis and distillation. So pretty soft. Very, very great water. So we're pretty lucky. So as you kind of creep up that scale, one of the issues you have is hardness. And that's, something maybe many people are familiar with, especially who've lived on the prairies. You're kind of dealing with too much calcium, too much magnesium, and it really does a number on appliances and faucets, especially where you're heating water. Because it precipitates out and you get that kind of white scaling. Nothing to worry about, but it's just mainly just an aesthetic thing, and it starts to, cause issues with appliances. So if you don't live in a city, you might get water from a well. And that turns out to be a lot of people. So like millions of homes, 30% of the population of Canada and 15% of the US. And just quoting from an older study, but I think one that's still relevant, that was done in the US, roughly a quarter of wells exceed max levels in one health impacting contaminant. And the big offenders were nitrate, which is likely fertilizer runoff, arsenic, and fluoride. So those are all ionic as well. So they all have a charge. 60% of the wells showed high hardness. So obviously not a health impacting issue, but definitely still an issue. Definitely a big issue in wells. A newer issue is in one that's happening locally, well, really globally, but especially locally too, is seawater incursion. So in the Gulf Islands, if you have a well, one of the things you might be worried about is it turning brackish. And you've basically got this tug of war between seawater and your aquifer. And so you've got maybe climate change on one end, you've got rising sea levels, pushing it in. But I think the bigger factor seems to me that we're just drawing down our aquifers too much. And it's, as a result, there's just not enough water to push back. So that's a big and growing problem. And, it doesn't, you don't have to do much reading to see that it's a big issue. I think I was just reading recently about problems in the Mississippi related to this. So, okay, so we've got obviously some issues with water quality. Drinking water treatment devices. So the basic way to treat that turbidity found in that Vancouver water is to use a sediment filter. They come in various sizes. Another technique is to use activated carbon filter, which it removes a lot of things, but I commonly hear people wanting to remove chlorine and essentially its byproducts. It'll also remove forever chemicals, pharmaceuticals, lots of things. So carbon filters and sediment filters are pretty common and often used together. Something that is used to fight microorganisms, so like small living things, would be UVC. And there's been a little bit of development there because of UV LEDs. So it's a bunch of new products on the market that utilize LEDs, which are just, they last much longer than the incandescent bulbs that were used previously. Next on the list would be water softeners using ion exchange resin. So if you have a hardness problem, this is sort of the main way to do it, to fix that problem. And it doesn't necessarily remove calcium and magnesium, it substitutes them with sodium. Now, if you actually need to desalinate your water, and you could be wanting to do that for a number of reasons. One, you've got a brackish well, and you just want to get the water down to something drinkable. Two, as in the picture on the right there, you might be Starbucks, and you basically want to remove everything from the local water supply and start from scratch. So their reverse osmosis systems will remove everything, and then they'll actually have to add minerals back. So when you go and drink their coffee and you drink their water, it always tastes the same. So they're kind of going for they've got a specialty beverage angle to this. Yeah, so sediment filters, carbon filters, they're like sub $100 kind of thing. Water softeners are in the kind of the $1,500 USD range. Reverse osmosis can vary anywhere from like sub 500 to like the stuff that Starbucks is using, which is like thousands of dollars. Okay, so just a little bit on reverse osmosis to kind of frame the conversation as we go forward here. I think everyone more or less knows how it works, but you essentially have a membrane, and you've got your saline water on one side, and you're forcing it through this porous membrane with high pressure, let's say over 100 psi. And because water is tiny, water molecules are tiny, that's the only thing that goes through the membrane generally. Things to remember about this technology: the cheap versions of it waste a lot of water. So you have to be running a lot of pure water over the saline side to flush the membranes regularly. So cheaper RO systems waste, let's say 75% of the water that goes into them, which is kind of incredible when you think about it, right? So that's one thing. And then you're obviously having to replace the membranes pretty regularly, and they're susceptible to chlorine. So some things to think about. Okay, now we'll talk about MCDI. So this is the eCaptis on the right with its...
One question.
Yep.
One question. Sorry, you just said that they're susceptible to chlorine. Can you clarify what you mean by that? Like, is it just break the membrane, or what?
Yeah,
What's the problem?
it just eats away at the membrane. I don't know too much about it beyond that. I don't know if CeeLo can comment beyond that, but no. Okay. Good question, Ryan. So yeah, MCDI on the right here, we've got the eCaptis itself without its cover panels on. You've got the module on the bottom, and you've got the plumbing and electronics on the top. And the module is what contains the membranes. And so if you look on the left there, I've got just sort of a crude schematic. If we think back to the reverse osmosis, you're forcing water with high pressure through the membrane. And with MCDI, you're actually forcing it across the membrane. So big difference, much lower pressures involved, just mains pressure, so 70 psi and less. And the main force here is, aside from the pressure, is electrical. So you've got an electric field, not that I haven't shown, which pulls ions to the sides of the membranes. And if we kind of zoom in on one of those membranes, so scale here on the right, you can see it's roughly 2 millimeters. And then you've got this stack starting with what we call the current collector on the top, which is something like graphfoil. You've got your carbon electrode, then you've got your anion exchange membrane, your flow channel, and sort of the opposite on the way out. So this is showing the purification cycle. So really saline water and all your ions on the left, and pretty pure water on the way out. In between, with an electric field applied, your cations are being pulled to the bottom and your anions are being pulled to the top. And then this is your purification cycle. So eventually what happens is these plates become saturated. And at that point, you'll pause the purification cycle and you'll reverse the voltage. And what will happen then is all of the ions will come back into the flow channel. But if you didn't have the membranes, the ions would just go to their opposite plates and you'd have the same problem in reverse again. But these membranes don't allow, for example, the anions to cross. The cation doesn't allow anions to cross, and vice versa. So they're really critical to the operation. And then you essentially send all these ions down the drain. And you can also do that at really, really low flow rates, thereby saving a lot of water. And that's, if we go back to the eCaptis, that's what all the plumbing is about and the electronics. So it's timing that, opening valves, and making sure all of that happens smoothly. Yeah, so kind of moving on to the eCaptis here, as a result, it can essentially remove anything ionic from your water, which is, a lot of things. A lot of those main constituents that we talked about before, the calcium, the magnesium, the sodium, the chlorine, lots of heavy metals, they're all ionic. Nitrates are another thing that it can remove. Another cool thing about it is that the output is tunable. So you can control the ppm output, and I should maybe elaborate on that a little further. This is just done with a conductivity sensor, so you don't really have any control over species. per se. It's just conductivity. But I will say that anything with a higher charge, you're pulling out with a higher bias. So, arsenic and lead, for example, have a higher charge. And so you'd be pulling those out more than you'd say be pulling out sodium, which is a good thing because you really don't want any lead in your water, right? So, yeah, it will move up to 1400 ppm to a max of about 2000 ppm. So just for a reference, seawater is like 35,000 ppm. So we're just really talking about brackish water at this point. And this is kind of the device's sweet spot in terms of like energy and those sorts of things. If you want to start pulling out more, you need to make the path length longer, or you just need to do multiple cycles, so you kind of lose efficiency there. So applications, obviously removing hardness is a good one. So the chief advantages there over water softeners is, I guess if you had a really high hardness, you end up getting rid of your hardness problem and adding a lot of sodium to the water, which may or may not could be a bad thing. Generally speaking, it's not an issue. But dealing with the salt, for example, replacing that, the craziest thing, there was like a salt strike for a very long time on the East Coast, so you couldn't get water softener salt. Another thing you might want to use it for is purifying tap water. So it'll compete really well with the more expensive RO systems. So Starbucks, for example, should probably be considering a device like this. It'll also turn brackish well water into potable water. So maybe just bringing the water into something that's drinkable, that 500 ppm limit, would be another good application for it. Yeah, so benefits, obviously much less water wasted than RO. So up to 95% of the processed water is available to drink. Typically it depends a lot on how much salt you want to remove, but an 80% water recovery is not unusual. It has a lower operating cost compared to RO. So that's just generally speaking, lower energy, fewer filter replacements, that type of thing. Another neat thing is you don't need to remineralize the water. So you're kind of keeping the amount of local minerals that you want. On the right, just kind of a miniature data sheet there. So produced flow rates are dependent on how much salt you want to remove. So anywhere from 50 to 500 gallons per day. I think I read that the average person uses 40 gallons per day. So this thing, depending on how much purifying it's doing, can support one person to a family kind of thing. It could also work in, say, a cafe, if you're wanting to make coffee. So, hundreds of cups a day, no problem. We do have NSF certification. So you need that to sell products for drinking water. You need at least NSF 61, and we've got NSF 42, which is rigorous. So some of the tests, it's all about, in this case, safety as opposed to performance. So making sure the device won't hurt you. And in this case, they do a leaching test. And they also do structural integrity tests. So over 100,000 cycles, pressure cycles, is one of the tests. So we've beaten it up pretty significantly, and it's working really well. Maybe I'll pause there. Any questions? Oh, Ryan.
You mentioned this before about the Starbucks application, and then I see it on the bottom bullet here. No need to remineralize the water. Why would you ever want to remineralize the water? Wouldn't the gold standard be just to strip everything out? I mean, maybe it might taste weird if you're expecting a certain kind of profile or something like that, but why would you want to remineralize the water? I'm confused by that.
I think it does if I think really pure water will give your coffee funny tastes. So I think you want somewhere in the 50 to 100 ppm range. I think it might make it more acidic. There's definitely like kind of a sweet spot, and too hard and not hard enough both have issues. So that's kind of why they're doing that.
Yeah, I think you're right on that.
Yeah. Mike's right about, very pure water will draw in metals and other things as well from your pipes. So that's another reason you don't want to be worried.
Pure water isn't as desirable a taste.
Yeah.
Doesn't taste good, and it's not necessarily good for you.
Yep.
The magnesium, and for example, is a life nutrient that's needed. So if you don't get it out of water, you got to find it someplace else.
That's absolutely right. Maybe we'll go to John here.
Yeah, thanks. I'm one of the 30% that's on a well, and my water is a little harder than I'd like it to be. So this is pretty cool technology. I was wondering about actually your last slide there, or your second last slide, where you showed the 50 to 500 gallons per day flow rate. I'm trying to envision how that relates to, like, does this system sit in line with your tap? So you turn on the tap and water flows through it, or do you need to have like it always going through and accumulating?
So if you're just going to implement kind of a point of use, as they call it in the industry, it would, I think either way, you're probably using some sort of bladder tank to accumulate it. So you get nice pressure whenever you open your tap, and your tap could be a special drinking water tap, or it could be your faucet. And the system, depending on the situation, is potentially big enough to do the whole home. So at that point, it would come into where the water enters your home, and it would just fill large bladder tanks. And it would do that throughout the course of most likely the evening. And so you just basically size your tank based on your needs. And you probably wouldn't want the system running 24 hours a day. So you're kind of thinking about that. Maybe it's running for half the day at most. So yeah, hopefully that answers your question. And
yeah, that's clear.
Yeah.
So like my UV filter just sits there and it's always on. So that, like, I turn the water on in the morning and it's like, is this cold water or is this warm water? So I need that.
Right.
Yeah,
and your UV system probably can it's in line. It can probably handle the flow rates, for on-demand use. And it's got a little sensor built in that'll like turn it on or off depending on whether there's flow. So,
yeah. All right. Thanks, Dustin.
Yep. And Chris Carpenter.
Yeah, so you kind of touched on this, but I'm just curious, because this pulls out minerals based on charge, is there any issue with being left with a weird minerals that you wouldn't necessarily want, or too much of like the lower charge minerals and have to rebalance minerals at the end? You're saying that like you don't really need to, but I'm not sure which minerals you'd want and which ones you wouldn't.
It's usually not. From what we've seen, it's not usually an issue. Essentially, it's going to take your like species profile, we'll call it, and just kind of lower it right across the board. That's generally what's happening. So you wouldn't get any like weird spikes of, everything that was in there before is just going to be in there again, except in lower quantities. And you might pull out a little more lead, and you might pull out a little more arsenic and iron.
But those are good things.
But those are all good things. Yeah.
Yeah.
So,
okay.
Mike. Oh, maybe he's muted.
Thank you. My question is pretty similar, being that like you kind of pull everything that has a charge out at once. So you obviously want to get rid of the lead and arsenic and things like that, but you would ideally like to keep some of the other ones. So like, is it tunable in that way, or yeah, how how, like, is it basically all or nothing if you have those things present in your water?
It's all or nothing. Yeah. So you couldn't tune for species yet. I mean, they are still working on membranes that might allow you to do that kind of stuff. But right now it's kind of all or nothing, which is still pretty useful.
Sure. Yeah, you can reintroduce what you do want, right?
Yep.
Yeah. So I'm also on a well here, and
Oh, great.
and we have like a 3-stage type of setup where, first of all, just a particle filter, and then for water softening, over the last year, we put in this device. It's called a Yarna. You can find it on Amazon, and you basically wrap the pipes in this copper tape, and it does electromagnetic pulses that have this capacitive effect that prevents the bonding of calcium and magnesium. And so it's an alternative way to do water softening without actually introducing any salts or you don't have to use a water softener. It just prevents scaling in your appliances and stuff. It's kind of an interesting approach too. Just kind of disrupts that process of bonding. And I presume that that's temporary. It's like while it's in flow, right? And so if you were to let the water sit for a while, they probably would then bond, but it's because you're pulling it out and using it. So
yeah, cool. I'll check it out. I haven't heard of it. So
Did you say electromagnetic pulse, Mike?
Yeah.
Okay. Does this like wipe your credit cards and phone if you go too close to it or anything like that?
Yeah, you got to wear a tinfoil hat if you get too close. Yeah. It's just like cycling some pulses through the pipe. Yeah, and then we have UV, of course, too. So I anecdotally think it's helped. We had scaling issues and staining on like porous countertop type thing, and so I think that's better now. It's hard when you already got it, and it's hard to get rid of some of it. But, yeah, wells are a bit of a pain that way. You know, but this is interesting. Oh yeah, one other follow up was like the distance of the travel through there is another thing you can control as a variable, right? Outside of this, so like amount of charge or distance are two different variables that affect how well the stuff gets pulled out.
Yep.
Is that right?
Yeah. So you kind of decide I get voltage is another one. You can change the voltage. So we've kind of dialed that all in. Obviously the module size is something you decide on pretty early. So, but yeah, those are all the factors that would kind of go into the design. Ryan.
I've got a bunch more questions.
Okay.
So you mentioned the NSF certification. Sorry, what is NSF again? I'm not familiar with that.
It's the National Sanitation Foundation. So these guys are basically a third party that have been certifying water treatment products for a very long time, to the point where you basically need their stamp to sell drinking water products. And they have a series of tests. We happen to choose 42 because it fit well for what we were going for. 61 is really common. And then they've got a few more. So they're like, a standards and testing organization. And they're a third party. And they also do, for example, to retain the NS42, they do unannounced audits of your company annually. And so they're looking for proof that you're still using the same materials to build the device and those types of things. So, and they charge you for it. So they charge you for that pleasure.
Wow.
But I mean,
stressful.
Yeah, it's a bit stressful, but you know, they give you this peace of mind, and I think a lot of people, you know, they look at your product and they see that it's got this third-party certification, and yeah, hopefully you sell more products as a result, and the industry is safer and all that good stuff.
Right. The 200 in the name eCaptis, what's that referring to? Because we talked about 50 gallons per day capacity kind of thing.
Yeah, it's for me, it was loosely about you know, kind of the average scenario, and so it's gallons per day. But there is quite a wide range because of the technology. If you're just kind of polishing the water and just removing, you know, few minerals, you could be getting up to 500 gallons per day, American gallons. But if you're really trying to remove everything, and you know, really going down to low ppms, like 10, 20 ppm, then you're going to be at a lower flow rate, more like 50 gallons per day. So,
Right. So when we had talked previously about the examples of a small commercial, you know, 500 gallon per day, that's the same unit that you're talking about, or is there a larger unit available also from Pureleau?
There is no larger unit available yet. But I mean, we're not alone in this industry. There is we do have a competitor, and they do have a larger model as well. So I think at some point we would consider that.
Right. Now you mentioned on this slide also that you're looking for demonstration sites in BC and Alberta. Are you focused on just continuing to develop the technology, or does Pureleau have a plan to kind of like help install them or partner with people that can make it easier to get them installed in their in-home residential applications or businesses?
We have partners already that are going to help us install, at least in BC. And so we're, you know, keen to start moving forward commercially here. And yeah, so we're looking for people who might have problem water. And we're going to be kind of accepting applications, I guess, if you will, because we're going to do the installation at no cost. And the goal really is case studies, and for for demonstration. So yeah, there's thousands of hours on these units already. We're very excited. They work really well. We've got a lot of certification, and so we're kind of moving to the next level here. So if you guys have any ideas, if you know of anyone, feel free to contact me or email info@pureleau.ca as well. I will note that our webpage is really bleak, not bleak, but sparse. It doesn't have any information about the eCaptis yet, but that's coming soon. But I can get you a brochure. So yeah, this is kind of a sneak peek for the Marine Beers crew.
Very cool.
Yeah. I really like that the savings in water, like in places where watering restrictions are a real thing, and that's more and more common now, like should be a good competitor to reverse osmosis.
Yeah, our competitor seems to be having a lot of success, and you know, slowly gaining traction there. I think the water recovery and saving water is a big thing. We can also customize the effluent. So if there are restrictions on the saltiness of the water that you can exhaust into the environment, we can also control that, which is pretty cool. And sort of just the tunability of the system is also really neat. So yeah. John, I think you had a question there, or did you?
Oh, yeah, fat fingers. But I was wondering, how much power does this unit take? Is it putting a lot of heat in, or is it?
It's not putting a lot of heat in. So it's like peak is 250 watts, but that's like for seconds. Generally speaking, we're talking about 100 watts here. And it does have an auxiliary pump that's very quiet and very low power, just to help fill those bladder tanks, just the end of the cycle.
Nice.
Mike?
Yeah, sorry if this was already mentioned. is there a element where you have to like remove filters over time and replace them? Like, are these membranes infinitely reusable, or how do you get rid of this stuff? How do you
Well, so some of the things that can happen over time, especially in like high hardness environments, where you get the scaling buildup. So it has a built-in citric acid cleaning system, so it kind of self-cleans periodically. The module itself does have to be replaced, but we're kind of looking at like 5-year lifespan here, so like pretty long time. And we're looking at ways to reuse a lot of the materials and kind of refurbish them back here. So hopefully, definitely you're replacing filters a lot less than RO. So they're lasting a lot longer.
Mm-hmm. And it's just one element of the unit you're pulling out.
Yeah, it would be that module. So it is a fairly big thing. Kind of like this big in this first gen array. Anyway. It's a technician. A technician would probably come in to do the swap.
Right. It's that infrequent. That's not too big of an ask. I think.
Yeah. Well, it looks like we've answered all the questions. Great questions, by the way, guys. Maybe we will wrap it up then. Really good to see everyone. It's been it feels like forever. So good to see all your faces.
Yeah, likewise. We're going to do this at in person again soon.
Hopefully, Chris Carpenter and I were talking about kind of a hybrid where we periodically do some in-persons and we keep doing the virtual. So last time we mixed it with James Rogers' business networking event, which is fun because he's getting like 15, 20 people out. And then so we can throw in some Marine Beers folks and we can chat and then we can meet some new people. So maybe we could try that again in the new year. We do have another speaker lined up for November. So I will be posting that soon. It'll be another virtual.
Cool.
Awesome. Well, thank you so much, Dustin, for the talk. It's really great to hear. I've heard you mention hints about Pureleau over the last sort of like year and a bit, and it's kind of very mysterious. And now we have an idea of what you've been working on so hard, and looks like an awesome application. And I particularly appreciated hearing a little bit about how I didn't know there was a problem with like saltwater incursion in water wells, and like for a province like BC where there's a lot of coastal communities, right? And a lot of remote communities. That's huge, right? So,
well, it's huge in the Gulf Islands for sure. Definitely ongoing issues there.
Yeah. So yeah, it's just really interesting to hear about all that. I really appreciate your talk. So thank you.
Thanks, Ryan.
Mm-hmm. Yeah, thanks, Dustin. Thanks for organizing. Nice to see you guys.
Okay. Awesome. All right. Well, we'll see you next time for the next talk in November for sure.
Yep.
Awesome,
Thanks, everybody.
Thanks, everybody. Bye.
Thanks, Dustin. Good presentation, and nice to see technology moving into water treatment.
Oh yeah, we're
The
excited.
other stuff's 100 years old, so
It is. Yeah.
it's cool. Very
Awesome.
much appreciated. Thank you.
And take care.
Bye.
Bye.